first shape in the sentence meet the definition of the second shape? And this is why that we stressed, or why I stressed, that you needed to know your definitions. So for rhombus, the definition of a rhombus is 4 congruent sides, a quadrilateral with 4 congruent sides. Does every parallelogram meet that definition? No. So that first one is false. Okay, I'm going to have pen issues this morning, apparently. Maybe not. Rectangle, what's a square? 4 congruent sides, 4 right angles. So rectangle does have the 4 right angles, but it doesn't always have 4 congruent sides. It doesn't have to. So this one is also false. Why is this doing this? There we go. This one's false. This one's false. Both 1 and 2 are false. Rectangle is a rhombus. Rhombus has 4 congruent sides. Rectangle doesn't. So that's false. Parallelogram is a rectangle. Does a parallelogram have to have 4 right angles? No, it doesn't have to have 4 right angles. So, oh, no wonder I grabbed the wrong pen. So that's also false. So far, the first 4 are false. A square is a rectangle. Definition of rectangle is 4 right angles. Does a square have that?
Yes.
It has that and more, so it's true. Trapezoid is a kite. A kite has 2, the connected sides are congruent, right? Does a trapezoid have to have that? No. And the trapezoid can only have what? 1 set of parallel sides. So when it says a kite is a trapezoid, a kite doesn't have to have any sides parallel, but it doesn't have to have only 1 set either, so this is also false. So the only one that's true so far is number 5. A square is a rhombus. Ashley, what's the definition of a rhombus? Yep, 4 equal sides. Does a square have that? Then a square is a rhombus.
Wait, but even if it doesn't have 4 right angles?
Well, a square will always have 4 right angles and 4 congruent sides, but it can also be called a rhombus because it meets the definition of being a quadrilateral with 4 congruent sides. Now the reverse, a rhombus is a square. That doesn't work because to be a square you have to have 4 right angles and 4 congruent sides, and the rhombus doesn't meet both of those, it only meets the sides part. A rectangle is a parallelogram. To be a parallelogram you have to have 2 parallel sides. Does a rectangle have that? So that's true. Kite is a quadrilateral. Quadrilateral has how many sides? 4. Does a kite have that? So that's true. Now if I said a quadrilateral is a kite, that would be false. It could be, but it doesn't have to be. It could be another shape. A rhombus is a parallelogram. Parallelogram has 2 sets of parallel sides. Rhombus does have 2 sets of parallel sides, opposite sides parallel. So that is true. So 5, 8, 10, 11, and 12 are true. And when you see problems like this on your BA, you're going to say, okay, here's my first shape. I know all of its definition and all of its properties. What's the definition of the second shape? Comparing it to the definition of the second shape, does it meet that definition? Square does meet the definition of a rectangle because the square does have 4 right angles. So that one worked out. Any questions on those type of problems? All right. Get down here. Exterior angles, sum and individual. Exterior angles, the sum of exterior angles is, as long as it's a convex polygon, is always 360. Oh, hopefully I didn't break my other pen. All right, so it's 360 degrees. So when they say find the sum, there's not much to find. You're just writing down 360. Because they asked for the sum. Find the sum of the exterior of a convex I don't care how many sides it has. If it's convex and an exterior, then the sum is 360. So for 13 through 15, it didn't matter that the first one, 13, had 12 sides, the dodecagon. 14 had 8 sides, the octagon. 15 had 5, the pentagon. The exterior angles are still going to add to 360. But the measure of each exterior angle. Well, I'm going to take the 360 since it's the exterior and it's a dodecagon. And what am I going to do to that 360? No. Divide. Since it's regular, every one of those angles is congruent. So I can split the 360 degrees 12 ways equally to get this answer. We'll do that in a second. Same thing here. Each exterior regular octagon. If it didn't say regular, I couldn't split it equally. But because there's 8 angles on an octagon, 360 divided by 8 will give me the measure of each exterior angle on the octagon. 360 divided by 5 will give me each exterior. You gotta be careful that it doesn't say interior, because that's something different, on a regular pentagon. So we're gonna do this real quick. I thought I opened my calculator. Hold on. Oh, there it is. Why didn't I see it down there? So I got 360 divided by 12, 360 divided by 8, and 360 divided by 5. We get 30, 45, and 72. Bless you. Any questions on those problems? So that's one of those theorems. We had those whole 6.1 summary theorem sheets where what are we supposed to know about exterior and how to find each, if it's regular versus if it's irregular. How do we find the interior? There's actually a formula for finding the interior. Anybody remember it? Yes, correct. N minus 2 and then times 180. That's going to give you the sum. That doesn't give you each angle, but it gives you the sum of what all the inside angles are going to add in the convex polygon. So when they say convex pentagon, we do 5 minus 2, which is 3, and then times it by 180. Either do it in parentheses or subtract it, hit enter, and then times 180, 540. For the octagon, is that 900?
Yeah.
900 is what you guys got, because that's 8
Wait,
minus 2.
I thought you were talking about, wait.
I have it down wrong, sorry, that was wrong. It's not 720 because that's a heptagon. 1080, thank you. For a dodecagon, that's 12 sides. Subtract 2 is 10 times 1800. 180. Put a little degree symbol. So I'm just using this formula to calculate the angles. But that's because they asked for the sum, that it's my final answer. When they ask for me to find the measure of each interior, well then I start with the sum, and because it's regular, all the angles are the same, so I divide by the number of angles. So the sum for 22, if they just asked this question out of the blue, I'd have to recalculate this, 540, and then I'd take that number and divide it by 5, which I think is 108. And then for the regular octagon, again, I would go through the process saying, okay, well, what's the sum first? Oh, here's how I get the sum. There it is, 1080. And I would divide it by 8, 135. And then for the regular dodecagon, again, I'd repeat this process and then divide by 12, 1800 over 12, 150. And that's how I would get those answers. Any questions on those? But it comes back to remembering how to find the sum. Some of the exterior is easy. It's always 360 for convex polygons, which are the ones we're working with. Some of the interior, follow this formula. Once you have the sum, you can figure out the rest of the problem. If it's regular, just divide by the number of sides. If it's irregular, we have to do something else, which is on the next page. Before we get there, though, they asked, are these regular or irregular, convex or concave? And name the shape in terms of the number of sides. Well, looking at these 9, or as there 12, yeah, let's just look at 6 at a time. There's 12. So let's look at these 6, 25 through 30. Are there any that are not polygons? 27 is not a polygon. How do you know it's not a polygon? Because it's got a curve, right? They have to be a two-dimensional shape with all side lengths as line segments. All vertices have to connect so that it's closed. If your little dog Fido was in there, Fido couldn't get out. Okay, or a rabbit or whatever. It looks like a rabbit. It's supposed to look like a dog, whatever. So it can't get out though because it's stuck in there and it has to be inside one area, one big area. 25. What type of shape is it? Let's do part C first. Yes, the Pentagon is shaped just like this in Washington, D.C. Is this one regular or irregular? It is regular because all sides are equal and all angles are equal. So it is regular and it is convex. How do I know if it's convex? 2 ways. It doesn't, none of the angles point in when I trace them. When I trace them to their vertex, that points away from the center of the shape. And this does that for all angles, so that works. So if I trace them, they're pointing outward. All points are pointing outward, not inward. Another way to tell is to check where all the diagonals are. If I connect all the diagonals, all of them would fall inside this shape. None of them would fall outside the shape. And so I don't have to worry about, it's going to be convex as long as all the diagonals are in the shape. For example, when we look at 26, it is concave. It's concave because this one points inward. But also, if I were to connect this point to this point, it would be a diagonal. It would cross outside. So that's how I know that that one is concave. Is it regular? No. Nope. Doesn't even have sides. Some of the sides are the same, but not all of them. Definitely not the angles. So it's irregular. Now, what shape? You got to count the sides. 1, 2, 3, 4, 5, 6, 7. 7 sides. Heptagon. All right, number 28. Convex or concave? If you think it's convex, raise your hand. If you think it's concave, raise both hands.
Wait, it's convex.
If it's convex, raise one hand. If you think it's concave, raise both hands. One hand is correct. This is convex. Is it regular
Yeah.
or irregular?
Irregular.
Irregular. It would have to have all sides the same exact tick mark and all angles the exact same angle mark. Yes, sir. Yep, I'll come and check it. And then it's got 4 sides, so it is a quadrilateral. Number 29. Miss Armstrong, what do you have for 29? Convex, regular, triangle, correct. Number 30 is not a triangle. In fact, it's a quadrilateral. It is irregular, and it is concave, because this one points in. Also, this diagonal connects outside. If you have not already tried 31 through 36, which most of you did, but some of you did not, please try those now. All right, so we're going to go a little quickly through these. This is a hexagon. It is regular, and it's convex. If there's one that you're not sure of or your question, speak up. This one's a quadrilateral. It is irregular, and it's convex. This one is irregular. I know it looks like they're all the same, but you have an angle here that's tiny, and then this angle is actually more than 180 degrees. So this is irregular. It is concave, and it has 8 sides, so it is an octagon.
Can you look at it and say since there's no like tick marks either?
Yeah, they'd have to have the equal tick marks, but sometimes they do, and we can't see it. I'll show you. We had one of those on the quiz. This one's a quadrilateral. It is irregular, and it's concave, because this caves in or points into the center. The last two are convex. One of them's regular, because it has all angles exactly the same, all sides exactly the same. This one, the sides are, but the angles aren't exactly the same. So it's irregular. This is a quadrilateral, specifically a rhombus. This is a quadrilateral, specifically a square. Now 37, 38, and 39, I really should have given you some different shapes for these. But is that angle outside, is that an interior or exterior angle? Exterior. And these are hexagons. And oh, it does say it's a regular polygon, so I know that all these angles here are the same, and so are all the outside angles. Now, some of you, when we did the exploration, after the exploration, you continued to find the inside angles first. And if you did that, how did you find the measure of the outside? If you knew this angle right here, how did you find this angle? They are supplementary. It's a linear pair, so you subtracted from 180. I don't do it that way. Most of you now are not doing that way, but some of you right after our exploration continued to do it that way and still do, and that's okay. So if you know that the exterior always add up to 360, but I don't have all 6 angles, I only have one of them, and it's regular, what am I going to do to that 360? Now multiply. Divide by 6, and that gets me 60 degrees. So this expression is equal to 60 degrees, and unfortunately 38 and 39, I should have changed the shape up to make it go through the process again. But if you do repeat the process, then you're going to get 60 degrees for this one, and 60 degrees for this one, and then it's a quick solve to find x. So for this one, x is 58. For this one, it's 52 divided by 4.
Wait, so it's just asking you to find that one.
Yes. No, they want you to find x. So in this case,
Always do 360 divided by the number of sides.
if it's a regular polygon and it's the exterior, yes, you would do 360 divided by the number of sides or the number of angles. When I'm doing n minus 2 times 180, I'm multiplying, but I'm trying to find the sum of the inside. 54 divided by 2. So all I'm doing now that I have these equations is solving by subtracting and dividing, or just by subtracting. How did I get x? So here I subtracted 2 from both sides. Here I subtract 8 from both sides, and then I get 4x equals 52, and I divide by 4. Here I subtract 4 from both sides, and I get 2x equals 50. Oh, I thought it was 57. Whoops, it's 56. So this is actually 20. Is it 20? Yeah, 28. I would have been wrong if I would have been 7. Other questions on these? So this is using exterior angle here. Now, this is still using exterior and its relation to interior angle. Some of you got confused because you're like, well, what do I use? The interior sum formula or the fact that they add the 360? Some of you also said, oh, there's only 3 of them. I'm going to divide it equally by 3. Are these expressions equal? So should you be dividing it equally? No. Only time you should do that is if they say it's a regular polygon and then it's all of them are equal. That's not the case here. So here, these are the expressions for the exterior angles. So what we have to do, why isn't this working? What we have to do is add them up, and what should they add to? 360, yes. Plus 4x plus 30 plus 3x plus 40 equals 360. When you combine like terms, the positive 3x's and the positive 4x give us 10x. That's a positive 10x. The minus 10 plus 30 is 20, plus 40 is plus 60, equals 360. Any questions so far? And the only reason I made it add to 360 is because it said that it was the exterior angles. If it had been the interior, I would have had to do the sum of the interior instead. So 10x equals 300. Divide by 10. X is 30. Now, there's 2 parts to this question. They want the exterior angles and the interior angles. When I plug this into these expressions, which ones am I going to get? Exterior or interior? Exterior. So I'm going to make a note. These are going to be my exterior angles. 3 times 30 is 90. Minus 10 is 80. 4 times 30 is 120. Plus 30 is 150. 3 times 30 is 90. Plus 40 is 130.
Is that just from plugging in?
I'm sorry?
Is that just from plugging in?
That's just from plugging x into these expressions. It gave me the exterior angles because it said these are the exterior angles on a triangle. But they also want the interior. This is where some people get confused unless they remember back to our exploration. Hey, Mr. Rader gave me all those. Wait, that's impossible. No, those are the exterior. That's okay. It's not impossible. I was thinking they're interior, thinking that's impossible. No, they're the exterior. So here's the deal. Here's our triangle. I know that one of these is 80, that one of them is 150, and that one of them is 130. How do I find the interior angles? If I know this exterior angle, how would I find this one? Subtract it from 180. It's a linear pair. They're supplementary. So to find part B, which is asking for the interior angles, I'm going to do 180 minus the exterior angles. And similarly, if I knew the interior angles and wanted the exterior, I could do 180 minus the interior. So this one, 180 minus 80 is 100 degrees. 180 minus 150 is 30. And 180 minus 130 is 50. These add to 180 degrees inside a triangle, just like they should. How did what? Yes. So see, remember, I think it was you earlier who said that those were supplementary, that they were a linear pair. So if I know one of them is 150, then I know the inside angle that's connected to it is 180 minus 80. This one's 180 minus 150. This one's 180 minus 130. Try this for the next problem, except this time it's not a triangle. What shape is it? So you have 5 angles that you're going to be finding the exterior. And what do the exterior add up to?
360.
If it was the inside, it would be adding to 540, but these are the exterior angles. So you'd make them add up to, do I want to divide it? Are they equally?
360.
It's going to add up to 360. Do I want to divide it by 5 though? It's not regular. These are all different expressions here, so I can't divide by 5. So give this problem a try. So if you combined like terms, added them up to equal 360, since it says they're exterior angles, Got 20 equals 360 divided by 2, x equals 18. Plugging it back in. We have 7 times 18, 2 by 18, which is 36, 3 by 18, and 6 by 18. So 126, 36, 54, 108. 126, 36, 54, 128, and another 36. These are the exterior angles when I plug 18 back into each of those expressions. How would I find the interior angles? Subtract 180 minus each of these. So for this one, the interior, that matches to that, is going to be 54. Yeah. For this one, it's going to be 144. For this one, it's going to be 126. For this one, it's going to be 52. And for this one, it'll be 144. And those angles should add up to 540, the sum of these inside.
I got 72 for.
Did I add wrong or subtract wrong?
108.
Which one? This one's 150. No,
I'm just kidding, I'm right there. Wait, what's the?
that's 126.
What is that, 106?
126. Now, I'm not going to go over the next two. I'll have the answer key available that you can check to see that you've done it right. But if in the next problem, it's like the same thing except it's 4 angles, right? So I do all the same process, but then instead of asking me for the measure of each, they ask me for the smallest interior. Well, could I find all the interior and then just answer with the smallest? Yes. Or if I think about it a little bit, but maybe it's better if I just find all of them and answer with the smallest. If I think about it a little bit, I could actually say, well, wait a second, the smallest interior matches up to the biggest exterior. Because there's something better. If they have to add 180 and you want the smallest interior, then you want the biggest exterior. But you don't need to think about that. And if it doesn't come to you naturally, you can just find all of them and answer with the smallest. I will have those answers available in a little bit for you to check those other two, or if you've tried them. Number 44, some of you remember this from when we did it earlier in the unit. -3, 5, 0, -2, and 3, 1. Now we have to be careful, and you have to be careful on the BA, and make sure you connect only points that are supposed to be connected. Can E be connected to F? Yes, because they're in order. They're next to each other in the statement. Can F be connected to G? Yes, because they're in the statement. If they weren't in the statement, then if they're not connected in the statement, then I can't connect them. And E is going to connect to H, and G is going to connect to H, but we have to find H. Which quadrant, quadrant 1, 2, 3, or 4, do you anticipate point H to be in? So either on the y-axis or in quadrant 1. It's going to be in one of those. So does anyone remember what we do? We have to follow the slope. And so I say, well, my point's up here somewhere. And so what I'm going to do is I'm going to follow this slope. I'm going to go from F to G would have the same as E to H, because it's a parallelogram, parallel sides. To get from F to G, I have to go up 1, 2, 3, and over 1, 2, 3. So I'm going to do the same thing here. Up 1, 2, 3, over 1, 2, 3. You're right, it is on the y-axis. To verify that point, though, I need to follow the other slope, which is to say this one from F to E goes up 1, 2, 3, 4, 5, 6, 7, and back 3. So up 1, 2, 3, 4, 5, 6, 7, back 1, 2, 3. It ends up in the same spot. at 0, 8. So if you got that, you did it right. If you didn't get that, hopefully you remember how now. There's also some videos on the whole website and some extra practice in 6.1 for that if you need extra practice. Oh man, more of these. Are they interior or exterior angles? Interior. So I'm going to find the sum by doing the n-2 formula. Should I divide that by the number of sides for all of these problems? No, because only one of them is a regular polygon. Which one? 46. For 46, since they are all the same, I could do 720, which is 6 minus 2 times 180. That's how I got the 720, divided by 6 because it is 6x when I add them all together. I'd get 6 x's. So it would be 6x equals 720 divided by 6. You're going to get your answer.
How did you get 720?
How did I get 720? And 6 minus 2 times 180 to get the sum. So because they give me a picture, I'm not going to automatically divide. I could for 46 just because they're all the same. But they're not all the same for 45 and for 47. I can if I wanted the exterior angles.
But you already had 98.
Oh, so yes. But I would write it out like this, but yes, I could do that. So there are 6 angles on here also. Again, 6 minus 2 times 180 is 720. So what I'm going to do is set up an equation. 3x plus 2x plus 2x plus 3x plus 90 plus 90. There's my 1, 2, 3, 4, 5, 6 angles adding the 720. Now, the 90 and 90 is 180, so yes, I will subtract it. I will combine my like terms and divide, and it'll give me the answer for x. Similarly with 47, it's still 6 angles, so it's still going to add to 720. But I'm going to do 90 plus 2, 4, 6, 8, 10 plus 10x. Or you can write them all out if you want and then combine like terms. And that'll help you solve for x. This looks just like our exploration. We actually had it with shapes where you were finding it, and then we made a summary table. Hexagon had 4 triangles. Heptagon. Yep. Heptagon had 7. Notagon had n. 64gon had 64. 88gon had 88 sides. 105gon had 105. N-gon had n. Number of triangles was always 2 less than the number of sides. That's where the n-2 came from. And then we took that and multiplied it by 180 to get the answer over here, which is where the whole n-2 times 180 came from. We saw a pattern, we put the pattern in the table, and we found the rule to be n-2 times 180 to get us the answers. So if you haven't already filled in your table, you can. But honestly, in your exploration, you already have up to here filled out if you looked back at your exploration. Now these are what our quiz was just on, and some of you went through already and made adjustments and said, oh my gosh, I can't believe I forgot to do that. Now I remember how to do it. Don't want to forget it by the quiz though. Looking at these expressions and knowing it's a parallelogram, what's true about this side and this side? They're equal. They're congruent. So 4w plus 8 equals 5w plus 1. Don't just set stuff equal because it has the same variable. It'll work out sometimes, but not always. So you got to make sure you know why you're setting it equal. What about angle E and F? Those both have a z in them. Should I just set them equal? No, because they actually are same side interior angles with parallel lines. So I should do 9z minus 12 plus 3z equals 180. That's going to help you find the value of z, the value of w, and plug it back in. Over here, w is 7, I think. For those of you who solved it, you can verify that. And over here, z, 12z equals 200. No, 192. 192 divided by 12. So 192 divided by 12. Yep, 16. Thank you. 16. So now I'm going to plug that in. 3 times 16, 3, 18, 48 degrees here. Well, that's going to be the same measure. Measure angle F is what they asked for. But I could have just as easily asked for angle D because they're supposed to be the same. Oops, that's supposed to be a degree symbol. Measure angle E would be 9 times 16 minus 12. Which is 132. But I could have just as easily asked for angle C because opposite angles are congruent. I plugged it back in, yeah. So now, if I plug in the 7 here, 28 and 8 is 36. 7 times 5 is 35, plus 1 is 36. So I get those answers. Any questions on that? Rectangles. Opposite sides are congruent also. This is what shape right here? What type of triangle? That's right, it is a right triangle with a side length of 5 and a side length of 12. So given that, could I find this length? What would I use? If they didn't give me any parts of the diagonal, could I find this? Pythagorean's theorem. If I look and say, oh, that's a right angle and I know this is 12 and this is 5, I can use Pythagorean's theorem to find the hypotenuse if I needed to. I don't think you're going to have to because they actually, you kind of lucked out on this picture. They even gave you part of the diagonal length. So since diagonals are bisected and congruent on a rectangle, something you're supposed to know, BD is 13. AC is also 13 because the diagonals on a rectangle are congruent. CD is also 5. AE is also 6.5, half of the full diagonal length. Uh-oh, rhombuses. I have some people who are still setting 9y equal to 2y plus 5. Can we do that? Are they the same length? They don't even look the same measure, right? The same degree. But what should I know about the angles of a rhombus, kite, and square? They are always perpendicular. So that 9y is actually equal to 90 degrees. When we divide by 9, y equals 10. Plug that 10 in down here. That makes this little tiny angle 25 degrees. Guess what the one next to it is? 25 degrees. This is a right triangle, so can I find these angles here and here?
Yeah.
180 minus 90 is 90, minus 25 is 65 degrees here. And that's also bisected, so that's 65. These are both 65. These are both 25 because we've got congruent triangles in our rhombus. Even more congruent than we have in our kite. So now when they ask for angle MNK, I just have to trace the angle and add expressions together possibly. MNK wants this whole angle, so I'm going to do 25 and 25, which is 50 degrees. They also asked for KL in the picture. I'm going to erase some of this because it's a little busy with all my angles. They also asked for KL, and unfortunately they didn't give me a side length. Does that really matter? Not for a rhombus, because all sides are equal. So just set these two equal. (2x equals 16, x equals 8). Plug it back in. 28 for all side lengths in that picture will be 28 units long, even if they didn't have an expression, because the other sides do. When you plug it in and get 28, all of them are 28. What shape is that next thing? A kite. And when we're solving and we have angles in a kite, we don't treat it as a kite, we treat it as 4 right triangles and find the angles, kind of like we just did with the rhombus. If you have not already tried the problems on this page, please do so now. So we are recording again, and we're going to take a look at these problems. So 51 in the rhombus, we had already talked about that, we did that. 52, you can see the kite. The angles were labeled that they labeled as 47. We know this triangle and this triangle are congruent, so I made those both 47. Subtracting from 180, since this is a right triangle, I subtracted the 90 and the 47 from 180 to get 43 here. This angle over here is also 43. They also told me the 98, B, C, D. They told me this whole thing was 98, but I know this piece is 43, so 98 minus 43 gave me 55 here. I solved this right triangle, 180 minus 90 minus 55, and got 35. Those are both 35. So now that I know all of the angles in the picture using right triangles, when they ask for ABC, A, B, C, 35 plus 35 was 70. When they ask for DAE, DAE is this little angle right here at A. That's the same as this, 43 degrees. And BCE is the 55. Any questions on that? Number 53, also a kite problem. Because they are right triangles, how can I find the sides if I know the diagonals? Use what?
You just add 1.4.
Do what? Well, it's not angles though, so I can't subtract from 360.
Well, I just do 124 and then do 124.
Oh no, I'm talking about 53, not 54, sorry. So you knew that these were each 5 because the short diagonals bisected. You knew this was 13. So you could find this piece using what? If I have two sides, Pythagorean theorem, have these two sides, 5 squared plus this was x, x squared equals 13 squared. Using Pythagorean's theorem, I got that to be 12. Apparently I didn't need it for that. Well, I will, because I'm trying to find AC. I knew that this was 18, and this is 5, so 5 squared plus y squared equals 18 squared. This was in one of our performance tests. When you solve, you get 17.29 if you do a decimal answer, and 12 plus that gives us our AC. They also asked for the length of AC plus BD, which is the 29.29 plus 5 plus 5. That was part of your one performance test that you did when we had the tape on the floor. But it will also be part of you actually making a kite using the diagonals that you find within the parameters to find the side lengths, and then also to find the angles. For 54, in an isosceles trapezoid, what are you supposed to know about the base angles? The base angles are the same, they're congruent. So angle K and L are both 124. Angle J and M are both whatever they are. With these parallel lines, L and M are supplementary, and K and J are supplementary because they're same side interior. That's how you get the 56, 180 minus 124. In 55, you know FH's whole length is 9. Well, in an isosceles trapezoid, and it should have said, well, it actually had it marked as an isosceles trapezoid, EG is also the same length, also 9. So if I know this piece, whoops, is 6.2, all I have to do is 9 minus 6.2, and I get 2.8 for that piece. In 56, they are base angles, so we end up setting them equal, solving for x. X is plus or minus 4, and that's all they asked us to find. If they asked us to find the angle, we'd plug that back in and get our angles. Any questions on that page? All right, I'll have the other answers available to you, but I want to go over a coordinate proof. And we're going to do this for the square. By definition, what would I have to show for a square? 4 congruent sides, 4 right angles. And how would I show 4 congruent sides? To show 4 congruent sides, I'm not going to go through these calculations. I will for the diagonals, but not for these. And 4 right angles. What would I calculate?
Distance.
Distance. I do the distance formula for sides. EF, FG, GH, and EH. I'd have to do the distance formula 4 times. Some of you don't like doing the distance formula, so you plot it in the plane, and you actually create right triangles, and it's basically the distance formula, but you use Pythagorean's theorem. If I'm going to prove that there are 4 right angles, what would I calculate? To be right angles, the lines have to have slopes. Do you want them to be the same to show right angles? What do you want them to be? Opposite reciprocals. Whereas for the distance, because I want them congruent, I do want them the same length. So we would have to find the slope of EF, the slope of FG, and those ones should be opposite reciprocals. The slope of GH, and those two should be opposite reciprocals. The slope of EH. And so all of these should be opposite reciprocals. They will have the opposite ones parallel. The other ones should be opposite reciprocals. Again, I'll have that available. The ones I really want to take the time to go over are the diagonals. So it might help for me to write down my points. I'm going to write them on the main board so I can still see them. You can obviously see them on your paper. -5, 0, -1, -2, -3, -6, and -7, -4. When they ask us to show the diagonals bisect each other, by the way, what are the diagonals for this shape anyhow? If I have this and they tell me it's a square, then it's E, F, G, H. Oops, that's supposed to be an H. What are the diagonals? Which ones are the diagonals? E, G, and FH. So when I do these calculations, it should not be for sides because it says, prove this about the diagonals. I better use the diagonals. Now what do I do to show the diagonals bisect each other? Find the midpoint. If they bisect each other, they should have the same midpoint. So I'm going to find the midpoint of EG, which looking at my points, that means I have to do -5 plus -3 over 2, bless you, and 0 plus -6 over 2. Well, that's going to be -8 on top. -8 divided by 2 is -4. This will be -6 on top divided by 2 is -3. So that's the midpoint of EG, but I also have to find the midpoint of GH. It's not erasing, okay. Midpoint, or FH, sorry, FH. For FH, it would be -1 plus -7 over 2, and -2 plus -4 over 2. It's going to be -8 over 2, which is -4. That's going to be -11, wait. No, that's a -2, sorry. -2 and -4 is -6 over 2, which is -3. And in fact, they are the same. So we're good. We just showed that they bisect each other because they have the same midpoint. Show the diagonals are congruent. By the way, we either write a statement before about what we're going to show. Hey, I'm going to show the diagonals bisect, or I'm going to show the diagonals are congruent by showing their distances are the same. So for the distance formula, if you're doing the distance formula for EG, then you have -3 minus -5 squared, and -6 minus 0 squared. Don't forget to take the square root, right? SD. Don't forget to do the square root.
Oh, yeah, you marked it down for that.
I did mark you down for that,
It was
yes.
just a symbol.
2 squared is 4. 6 squared is 36, so this is the square root of 40. In simplest radical form, the largest perfect square that goes in is 4, so that would be 2 square roots of 10. If I didn't say give an exact answer, you could give me a decimal approximation for square roots of 40, especially if we were measuring something, but if it's for an exact answer, that's the answer for EG. For FH, Again, trying to show they're congruent, we're calculating the distance. So for FH we have -7 minus -1 squared plus -4 minus -2 squared, and we're taking the square root. This becomes plus, which makes that a -6. Squared is 36. This becomes plus, which makes that a 2, which squared is 4. 36 and 4 is 40. So we have the square root of 40, which again is 2 square root of 10 as an exact value. So they are congruent. Any questions on that? And lastly, to show the diagonals are perpendicular, what do I have to calculate? Slope. And they are perpendicular if slopes are opposite reciprocals. So, for the slope of EG, I have -6 minus 0 over -3 minus -5. That's -6 over 2, which is -3 over 1. For the slope of FH, I have -4 minus -2 over -7 minus -1. That becomes -2 over -6, which reduces to positive 1/3. These are opposite reciprocals, so they're perpendicular. Now the other problems where they tell you find this, show this, are the same thing. If they're asking you to show the diagonals are perpendicular, you just do slopes, you show their opposite reciprocals. If they're asking you to show that opposite or that diagonals are congruent, you find the distance. If they ask you to show that they're bisect each other, you find the midpoint. Okay? And we also had proved shapes by their definition or by the properties of their diagonals. You'll have the ability to do that as well. Any questions on those? I'll have the answers up in a second.